Hello everyone. In this video we're going to talk about how to find an inverse function. So for finding an inverse function, what we want to do is switch the input and output values. And what I just note to you is that usually we're swapping the x and y values, but it doesn't necessarily have to be so, because like we've talked about in class before, my input could be a different variable and so could my output. Alright, and then last you want to do is solve for your output, and then that will give you the inverse function. Okay, and so here's an important note. Okay, that's a very important note here. If f inverse of x is the inverse function of f of x, then we have these two properties here, which means that the composition of f inverse and f is equal to x, and the composition of f of f and f inverse is also equal to x. So if I plug in my function f into the inverse function, I should get out x, and then if I plug in the inverse function into my function f, I should also get out x. Okay, so that's a good way for you to check right now if in fact what you found is the inverse function, if it's correct. For later on, we'll want to know these properties just when we're talking about logs and exponential functions, because they're inverses of one another. Okay. So for example, when I want to find the inverse function of y is equal to the cubed root of x minus 1. So what I'm going to do is I'm going to swap the x and y. So I have that x is equal to the cubed root of y minus 1. Okay. So I swap y and x, and then I want to now solve for y. Okay, because what you notice here again is that my y is acting as my output, and then my x here is acting, my x here is acting as my input in this case. Right, because if I plug in something for x, that will give me an output value for y there. Okay, so now how do I solve for y? Well, somehow I need to get rid of this cubed root. So what you want to do is you want to cube both sides of the equation, all right, to get rid of the cubed root. So remember, we've gone over this before with when we talked about how to get rid of, like when we talked about roots and things like that, and how to get rid of the cubed root would just be to cube it, and so what you get is what you're left with inside the root there. Alright, you might have seen this before also in Algebra 1 or geometry. Okay, so then from here I get that x cubed is equal to y minus 1, and now to solve for y, I'm just going to add 1 to both sides. And so what I'm left with is x cubed plus 1 is equal to y. Okay, so that's what you should get as your inverse function. Okay, so now you might have done this a little bit before with your other teacher from what I've seen in the notes, but now what you want to do is we're going to get a little bit more sophisticated. What if I don't have y equals and then something in terms of x? What if I have a different function here, like v of t? Right, so here I have my function v of t is equal to 3t minus 2. Alright, so the same process happens where I switch the input and output, I swap them. So in this case, my input is t and my output is v of t, so I'm going to switch those, so I get t is equal to 3 times v of t minus 2. Okay, and so we can see that's what I did here, right? So I just switch these. Okay, and now what I want to do is solve for v of t. Okay, so now I'm going to add 2 to both sides. and then divide by 2. Divide by 3. So then what I get here is that t plus 2 divided by 3 is equal to v inverse of t. Okay, and so if you got confused by why I started writing v inverse of t, originally you can say, oh, well then this is v of t. Okay, but remember, this is the inverse of v of t. It's not exactly what v of t is. And so when we get to this step here, we say, oh, well then this is just v inverse of t. Okay, so now I want to actually check that what I found was in fact the inverse function, and that's how we denote the inverse function of v of t, which is v inverse of t with that -1 right above there. Okay, so what I'm going to do is I'm going to say, all right, well I need to check that v inverse of v of t is equal to t. And I need to check that v of v inverse of t is equal to t. Okay. So I want to just note here on the side what they even are. So again, v of t was what we were given in the problem, which is 3t minus 2. And then v inverse of t, the inverse function that we found, was t plus 2 divided by 3. Okay, so if I want to find, first if I want to deal with this here and I want to show that v inverse of v of t is equal to t, what I'm going to do to figure out that composition is I'm just going to plug in v of t into the inverse function. So I want to plug in 3t minus 2 into the function. So wherever I see t, I'm going to plug in 3t minus 2. So here, when you plug it in, you get 3t minus 2 plus 2 over 3. Okay, and then how would I add the 3t minus 2 plus 2? Well, that would just become 3t plus 0, which is just 3t. They would cancel. And then 3t divided by 3 gives me t. Okay, so I've checked that condition. Now I need to check the next one. So I need to check that v of v inverse is equal to t. So I need to plug in the inverse function into v. So I need to plug in t plus 2 over 3 into v. So wherever I see t in v of t, I need to plug in t plus 2 over 3. So I have 3 times t plus 2 over 3 minus 2. Okay, and so what we have here is we have 3 times t plus 2 divided by 3 minus 2. And when we simplify this rational expression, we see that these 3's cancel here. So we're left with t plus 2 minus 2, which is just equal to t. And so we verified that, in fact, v inverse of t, the inverse function that we found, is in fact correct. So t plus 2 divided by 3 is in fact the inverse function of v of t.